Hi everyone, welcome to the channel. We're going to be solving question 35 from the first chapter of the Johnston textbook. And we have a steel pipe of 400 millimeter outer diameter that is fabricated from 10 millimeter thick plate by welding along a helix that forms an angle of 20 degrees. So let's just write down the givens that we have so far. So we have a steel pipe. We know the outer diameter. We can show it with DO is 400 millimeter. And also we have the thickness of these plates that we know is 10 millimeter. And we have the angle of the helix 20 degrees. So we know that the force P that is applying on top of this is 300 kilonewtons. So our P is 300 kilonewtons. And we need to determine the normal and shearing stress in direction, respectively, normal and tangential to the valve. So if you look at this from the point of view of this guy, what we're gonna see is something like this. So we have this right triangle that makes 20 degrees, and we have this surface of A, which, as we can see, we have a hollow cylinder. And if we look at this pipe from top, we're gonna see something like this. So if you look at the pipe from the top part, we know that the outer diameter, which is from here to here, is 400 millimeter, and we know the thickness of each, or the ring that we have, is 10 millimeters. So if we want to find the inner diameter, I'm going to show it in red, which is what we have from here to here. If we want to find it, basically we have 400 minus 2 times 10, or 380 millimeter. So the area that we have in here, we can call it A. If we look at it in 2D, this will be our area, so this will be A. And if we want to find our A, it's pretty easy. Since we have D, we have pi over 4, and we have the outer diameter minus the inner diameter squared. That way we can find the area, and as I said, the inner diameter in here is 400 minus 2 times the thickness, which is 10 millimeter. So 380 millimeter. So now we should be able to find the diameter in here, but the force P that we have in here is this force P. But what we are interested in here is the force perpendicular, or the normal and tangential force in here. So this angle here would be 20 degrees too. So the normal component would be P cosine of 20, and the shearing force in here would be P sine of 20 degrees. And also we have a right triangle. If we want to find the area of this part, or A prime, we know that if we do a cosine of 20 degrees, we're going to have our A over the hypotenuse A prime. So our A prime would be A over cosine of 20 degrees. Now we are looking for two things. First, the normal stress, and second, the shearing stress. Let's start with the normal stress. So we have the normal force into that surface, which is P cosine of 20 degrees over the area. The area that we have in here is the A prime, not A. So we have A over cosine of 20 degrees. So this will be equal to P. This cosine can go into the numerators, so it will be cosine squared of 20 degrees over A, which is pi divided by 4, and we have 400 squared minus 380 squared. We can calculate the normal stress here. So from the question, we know that the force P is 300 kilonewton, so 300 times 10 to the 3 Newton times cosine squared of 20 degrees, and we have pi over 4, Again, 400 squared minus 380 squared. And since the unit is in millimeter, we're going to multiply it by 10 to the minus 6. And that way we're going to get it in meters squared. So actually we can keep this 10 to the minus 6 and bring it to the top. So it will be positive. So I'm just going to explain this here. So times 10 to the 6. So whatever value for this one we have, which is going to be in Pascal, this is going to be our mega. So we can find our stress in megapascal. So let's calculate this, see what we get. So 300 times 1000 times cosine of 20 squared divided by pi over 4. That's going to be, and we have to divide this by 400 squared minus 380 squared. So this is going to give us 21.62. As I said, 10 to the 6 is going to make this to megapascal. And that's going to be our normal stress for this question. And the second part, we have to find the shearing stress. So let's figure that out. This time our tangential force or our shearing force is P sine of 20. So P sine of 20 degrees over the same thing, A over cosine of 20 degrees. So we're going to get P sine of 20 times cosine of 20. And the area or our A is the same, pi over 4. 400 squared minus 380 squared, and we're going to get a 10 minus 6 in here, or we're just going to bring it up 10 to the 6. So again, this will be our mega, and this is going to be our Pascal. So let's figure this out. So same force, 300 times 1000 in order to get it in Newton, times sine of 20 times cosine of 20 degrees over pi over 4. 400 minus 380, 100. So let's calculate this one now. So 300 times 1000 times sine of 20 times cosine of 20. Now we're going to divide that pi divided by 4. And we're going to divide the whole thing by 400 squared minus 380 squared. And that's going to give us 7.87 megapascal. And the final answer for this question. Hope everything was clear. Let me know if you guys have any questions. We are covering different textbooks in this channel. Let me know if you have any specific problem that you want me to cover in the next videos. And you guys take care. I'll see you in the next one.